Hello everyone. So we are continuing with our LeetCode series of top 100 liked questions. And in this video, we'll discuss this search a 2D matrix. So a question is you are given a matrix of size m cross n. And so there are some properties of this matrix. First is each row is sorted in a non-descending order. Non-descending means that we can say it is in a ascending order with values equal as well. The second thing is, so it is like each row is sorted, okay, as we can see in the example. The second is first integer of each row is greater than the last integer of the previous row. So for example, in the row 1, the 10 is greater than 7, 23 is greater than 20. So these are the two properties of this matrix, and we will see how that helps us. Now you are given an integer target and you have to search the target in the matrix and return true or false if it is found or not. And your solution should be log m cross n. Okay, so log size of the matrix. So this is the input. For example, if the target is say 3, you return true. If the target is say 13, you return false. And the constraints are the size is 100 by 100 and values are 10 is power 7. So the constraints are pretty similar. Now let's see how we will solve this. Now, before we start, there are multiple ways to solve this problem. But the way I will teach you is very, very simple and very, very small code. And very, very easy to understand as well. So once you understand this logic, you don't have to go anywhere or for any other solution. Okay, so this was our input. So it is saying matrix is, so each row is sorted in the matrix. And the second is each row value, the first value of each row is greater than the previous row last value. Okay. So if you think about it, each row is sorted and each row first value is greater than previous row last value. If you combine these two together, if you combine these 2 points together, what will you get? We can say entire matrix is sorted. Entire matrix is sorted. How we can say that? For example, if you look at it, 1, 3, 5, 7, then 10, 11, 16, 20, then 23, 30, 34 and 60. It means if you traverse the matrix row by row from left to right, you can see this whole matrix is sorted. And the question is, we have to find the target in the matrix. Now, it is like a binary search. The matrix is sorted and we have to search the target. But binary search works on a 1D array. Right? If we have a 1D array, we can directly do the binary search. But here, I can convert this matrix into a 1D array. Why? Because if you think about it, if you imagine it is only a 1D array. So let's write that 1D array. It will be like 1, 3, 5, 7, then 10, 11, 16, 20, 23, 30, 34 and 60. So actually this entire matrix is sorted and we can treat it as a 1D array. But the problem is we are not given a 1D array, we are given a matrix. So can we convert this matrix into the 1D array? I'm just trying to boxing it in. Okay. Actually, let's index this. Okay, so what will be the index of the array if it is a 1D array? So this is the index. This is the index. Okay. Now let's see, can we map that index to this? So what we are saying, indexing should be like this is 0, 1, 2. So this indexing we want to this matrix, but currently matrix is indexed at 0 1 2 and 0 1 2 3. This is row and this is column. Okay, but let's see, let's look at this 6. 6 should map to row 1 and column 2. Okay, now we will need some modular operations here. For example, if I say what is 5 modulo 4, 5 modulo 4 is 1, and what is 5 divided by 4, the integer division, it is 1. So I can say 1 comma 1. Is 5 at 1 comma 1? Yes, it is at the first row and first column. Now let's see another index. Let's look at 10. What is 10 mod 4? 10 mod 4 is 2. What is 10 divided by 4? It is also 2. So we can say 10 is mapped to second row and second column. Okay, now let's look at the 7. What is 7? 7 mod 4 is 3 and 7 divided by 4 is 2. So it is 2 comma 3. So 7 is, yes, it is not 2, it is 1. If you divide 7 by 4, it comes out to be 1. Integer division. So it is 1 comma 3. So first row and third column. So this is what we can use. So what I am saying is, when you have, if you consider this entire matrix as a 1D array, and if you use the indexes like this 0 till 11, for each index you can get the corresponding row and column of that value, and using that you can fetch this value. So what is the starting index of the 1D array? The starting index is 0, and what is the ending index here? Ending index is 11, but what is 11? 11 is actually n into m minus 1, because there are n into m values, so it is 3 into 4 minus 1, which is 11. So basically, instead of searching in a 2D matrix, we are only searching in the 1D matrix. So let's see the code and then you will understand. So now let's first find the row and columns. So row is matrix dot size and column is matrix 0 dot size. Here I am saying n as the number of rows and m as the number of columns. Okay, now we are just using the normal binary search. So what we will do, we will say L equals to 0 and R is equals to n into m minus 1. Now what we will do, simple binary search, while L less than equals to R, int mid is equals to L plus R by 2. Now we have this mid value, but now I want the row and column value. So how we will find the row? So row is equals to mid divided by m, and call number is equals to mid modulo m. Now we will just check if matrix of row column is equals to target, we return true, else if this value if target is less, then we will do R is equals to mid minus 1, else L is equals to mid plus 1. Very simple regular binary search. And now finally yeah, so it will return true or false here, and if nothing is found, return false. So let's run this code. Okay, now let's submit it. So this, we are done. So now if you see, instead of searching in a 2D matrix, there are many solutions which says how to search properly in this 2D matrix. But instead of that, I have told you a very simple method that you can treat this 2D matrix as a 1D array, and you can do a regular binary search on the array, and the indexes you can convert to the row and column value of the array. Okay, so if there is any doubt that why this is working, let's quickly look at that as well. That if you see, the first row is 0 1 2 3. When you go to the 4, the row increases, so it is like it is in the chunk of every 4 values. So in that is why we are doing modulus 4. So it is basically number of columns. So you do modulo on number of columns, and when you do modulo, it will give you the column number. So for example, 0 4 8 all have modulo 4 equals to 0. 1 5 9 modulo 4 is 1. So modulo gives column number, and divide by 4 gives you the row number. So 0 1 2 3 all divided by 4 is 0. 4 5 6 7 all divided by 4 is 1. So divide gives you row number and modulo gives you column number. So with that, we are done with this question. If you like this question, please like this video. If you want to see more such videos, you can subscribe to my channel to receive notifications. I have also created a LeetCode playlist, so you can visit that playlist, and it contains all the videos so far. So I'll see you in the next video.